Here is a custom RC plane designed in Solidworks. There are several systems of moving components, including the propeller DC motor system, the ailerons, elevators and rudders, and the wheels. Additionally, there is a compartment to place 2 AAA batteries to power the plane, covered by a snap-in lid. It is important to understand how the plane generates lift before further exploring its control systems. There are 2 schools of thought regarding how the shape of an airfoil creates lift. The Bernoulli principle explains that the wing splits the air, with the air going over the top moving at a faster speed than the air going under the wing. Given that the speed of the air over the top of the wing is quicker, there's less pressure on the top, pulling the airplane upward. The Newtonian way of thinking explains that because there is always an equal and opposite reaction to a force, when the wing is hit by air, it gets pushed upward, thus creating lift. The RC plane generates propulsion to move forward using a propeller system at the nose of the body. This system consists of a propeller cap, 2 propeller blades, and a DC motor connected to the propellers with a rotor rod. For the motor to function, 2 magnets are found along its walls surrounding a central rotor containing coils of wires. As electricity from the batteries flow into the motor, it flows through the coils to generate magnetic fields. The resultant magnetic force interacts with the 2 magnets to cause rotational motion in the motor, which in turn helps it to spin the propeller blades. The blades are angled to push air backwards, thus creating a reaction force to propel the plane forward.
Next, we'll take a look at how the plane changes direction. The plane has 3 separate axes of movement due to its 3 separate control surfaces. These are made up of smaller, moving sections on the wing and the tail. To begin with, the aileron system consists of the ailerons themselves and a rod going through the wings and ailerons. Each of the control systems move by rotating the rod using the same battery and motor system as the propellers. Being located on the wings, the ailerons can move up and down to redirect airflow, allowing for the plane to rotate. Next, the rudder, found on the fin, has a similar assembly as the ailerons, with the control surface of the rudder itself and the controlled rod. It moves left and right to control airflow for changes in yaw. Finally, the elevator is located on the tail of the plane. The movement of the elevators up and down is by the same system as the last 2 control surfaces, and it causes a change of pitch, which is the rotation of the plane about the lateral axis. The landing gear of the RC plane is composed of a leg, wheel, pin, and nut for each of 3 points of contact with the ground. The leg is attached to the RC plane with glue, with the wheel secured in place with the pin and nuts. The pin is smaller in diameter than the hole of the wheel and leg so that it can rotate freely. This in turn enables the wheels to experience 360-degree rotation for rolling on surfaces.